Welcome to CM1 class 1 of Word. First we'll do the very basic shortcuts of whichever what we use in daily life of our Word classes, and then we'll be moving on to the chapter questions of time value of money and interest rates. Okay, so first to open a new workbook, Control N. Control N will open a new workbook for you. Then Control plus N. So this is a new workbook. Control plus N is new workbook. A new document instead. Say new document, and then how did I select this? Shift and up arrow key. Shift and up arrow key selects all the text in that line, and then Control Shift greater than signs will increase the font. Control Shift less than signs decreases the font. Control Shift greater than sign. Control Shift less than sign. Okay. Control Enter brings you to the next page, so that you don't have to press Enter every time. You have to come to a new page. Control Y is redo. Control Z is undo. Okay, and then if you are writing something and if you have to come to the superscript or subscript of it without the equation format, so Control equals to brings you to the subscript. Control equals to again brings back you to the normal one, and Control Shift equals to brings you to the superscript, and Control Shift equals to brings you back to normal. So Control plus equals to is subscript. Control plus Shift plus equals to is superscript. Okay, so this is the very basic shortcuts which we'll use very normally every day. And now moving on to the chapter questions. Before that, Alt equals to inserts equation. If you want your equation on the left hand side, just press this arrow key on the equation design tools and set this justification to left. Click on defaults, press yes and press OK. So this will always set your equation to default left. Okay, it will not be in the middle of the line. Once this is done, now let us move to the question. Calculate the annual effective rate of interest for a transaction in which 200 is invested for 18 months to give 350. So you have to calculate I for a transaction in which 200 is invested for 18 months to give 350. So first question 1. Alt equals to 200 into 1 plus I, brackets close, to the power. To the power appears on Shift and 6 key of your keyboard, and then 18 divided by 12. Okay, because it's in months, and press equals to 350. Okay, now you have to solve for I, which you can do obviously in your calculators, solving for I. So therefore Alt equals to I is equals to 350 in brackets 350 divided by 200 to the power 12 by 18 minus 1. So this gives us the value of 0.4522, which is equal to 45.22%. Okay, so this is part 1. Coming to part 2 of this says a transaction in which 100 is invested for 24 months and another 100 is invested for 12 months, starting 12 months after the first investment to give a total of 350. So here the equation will now become 100 into 1 plus I, and then to the power 2 plus 100 is invested after 12 months. So 100 into 1 plus I. Then this is equals to 350. Okay, and Alt equals to, if I divide this equation by 100, I get what? 1 plus I ka whole square plus 1 plus I, which is equals to 3.5. and then you can just solve this quadratic equation, or using your calculator you can solve this to give a value of I is equals to my 1.4365 or minus 2.4365. Obviously 1.4365 is valid. 1 plus I is equal to this. 1 plus I is equal to this. Therefore, I is obviously equals to 43.65%. Okay. So this is my answer to first question. Next question is question 2. A 182-day treasury bill redeemable at 100 was purchased for 96.50 at the time of issue and later sold to another investor for 98 who held it to maturity. The rate of return achieved by the initial purchaser was 4% per annum effective. Calculate the length of time in days in which the initial purchaser held the bill. So first, for the initial purchase, again IFoA has this rule that you have to complete each question, entire one question, start entire one new question on a different sheet of the document. So control enter brings us to different sheet. Question 2, and now first part. So length of the time, first alt equal to, for the first thing we have 96.5 was there into 1.04 to the power t, which is equals to 98, and then alt equals to taking log on both sides. We have log of 96.5 plus t log of 1.04 is equals to log of 98. Okay, so equals to, alt equals to, then rearranging this we get t is equals to, in brackets we have log of 98 minus log of 96.5 divided by log of 1.04 space. So this looks like this, and after solving this obviously you will get the value of your t is equals to 143.545. okay, so this gives me the value. Obviously after you convert this to days, so this into 365 we have to do, so get it to convert it to days, or about 144 days. Next part to the question says calculate the annual simple rate of return achieved by the second investor. So for the second investor we need to do is, since the original investor held the bill for 144 days, the bill was held by the second investor for, so you need to write this, since the original investor held it for 144 days, second investor held it for 182 minus 144, which is equal to 38 days. Okay, so now we have to calculate the simple rate of return. So 98 into 1 plus 38 divided by 365 I is equal to 100. So solving this for I is equals to 100 divided by 98 into minus 1 into 365 divided by 38. So this gives us a value of 19.603%. So this is I, and third part to this was calculate the annual effective rate of return achieved by the second investor. So for the annual effective rate of return, it is same thing, alt equals to 98 into 1 plus I to the power and then 38 by 365. Okay, so this is equals to 100. So I is equals to 100 divided by 98 to the power 365 divided by 38, and this is equals, and this minus 1, so this is equals to 21.42%. okay, so this was your second sum. Also we have done it, and it's almost similar. There's nothing new in this, just putting powers and spaces. Okay, and then you have a 182 next question 3, calculate the accumulated value after 6 months of an investment of 100 at time 0 using the following force of rates of interest. So you have to calculate the following force of rates of interest based on the basis of force of rate of interest. You have to calculate the following accumulated value after 6 months. So again, control enter question 3, and then we have this accumulated value. So AV is equals to alt equals to 100 e to the power 100 e to the power 0.5, and then we need to write delta. So backslash delta, delta space brackets close space, okay, and then you can just put your values 100 e to the power 0.5 into 0.05. So space, this is equal to 100, so 102.53. Okay, next question is part B to this is a rate of interest of 5% per annum convertible monthly. So next is 100 convertible monthly is alt equals to 100 into 1 plus I to the power, double brackets please, 12 brackets close divided by 12. So this becomes I12 by 12. Again see it, I to the power double brackets 12 space divided by 12 space brackets close space is equal to, no, then to the power 6 months, okay, is equals to 100 into 1 plus 0.05 divided by 12 space to the power 6 space is equals to 102.53. Okay, and then part C to this is an effective rate of interest of 5%. So now 100 alt equals to 100 into 1 plus I to the power 6 by 12, obviously now it's in yearly thing. So 100 into 1.05 to the power 0.5, which is equals to 102.47. So this solves this question as well, with a very easy question. There's nothing new in this, very simple, but you can see it's so simple solving all of these, not take time much. Question 4 is the force of interest at time t is given by delta t is equal to 0.04. The force on 0.04 plus 0.00 t for 0 less than equals to t less than equals to less than 10, and then 0.015 t minus 0.08 for 10 less than equals to t less than 12, and 0.07 for 12 greater than equals to t. Determine the expressions for the present value at time 0 to 1 of money at time due at time t. So how we'll do this? Again press Ctrl Enter, comes to the next question 4. Okay, now we'll obviously write different times. So first, for equals to 0, less than and equal to sign of your keyboard, t, and less than 10. 0 and less than equals to will become like this sign, and then t is equals to 10. So when you have to calculate Vt for this, discounting is equals to e to the power minus backslash int, e to the power minus backslash int space, backslash int space will give you this, underscore 0 to the power t, underscore 0 to the power t, and space will give you the limits. Okay, and then you can write your equation 0.04 plus 0.002 s ds. Okay, so this completes our values, and then you can just put space, so it will go into the power. So this is ds, and then you can solve it. Alt equals to Vt is equal to then e to the power minus of, in brackets we'll solve it, 0.04 s plus 0.001 s square, brackets close, underscore 0 to the power t space gives the limits, brackets close, and space. Okay, this gives us the values, and then for alt equals to, again we'll write e to the power minus 0.04 t minus 0.001 t square, space, brackets close, and space. Okay, so this completes our first part. Now alt equals to when 10 is less than equals to t less than equals to less than 12. So now we have to again use two discounting factors. So what we'll do is we'll set t equals to 10 in the, obviously t equals to 10 in this equation. So e to the power minus 0.04 into 10 minus 0.001 into 10 square, brackets close, space, and into the discounting factor of the next portion, which is e to the power minus backslash int underscore 10 to the power t, and then you can just solve it 0.015 s minus 0.08 ds. Okay, solving for this, brackets close, space, this goes up in the numerator, then alt equals to, this portion comes up to, if you solve this will come up to e to the power minus 0.5. Okay, this will come up to e to the power minus 0.5, and we'll solve this portion, e to the power minus of 0.0075 s square minus 0.08 s, brackets close, underscore 10 to the power t, brackets close, and space. And then if you calculate this will become alt equals to, directly this part when I'm writing, e to the power of minus 0.0075 t square plus 0.08 t minus 0.55, brackets close, space. So this will come up to this value for 10 less than equals to t and less than 12. And for the third part is when t is greater than 12. Okay, so alt equals to again vt, and what we'll do is we'll put t equals to 12 in this original equation which was there, just copying this equation so that I don't have to write it again. Control V, just put the values of t, so into 12 square into 12 minus 0.05, and in alt equals to e to the power minus backslash int underscore 12 to the power t, and then 0.07 ds, brackets close, space. So this is the value. So alt equals to, this will give me a factor total when I solve this gives me e to the power minus 0.67, and this will give me e to the power, brackets open, minus 0.07 s, brackets close, underscore 12 to the power t, brackets close. And then coming to the next line, alt equals to, this will give me e to the power minus 0.67, e to the power minus 0.67, and then last one is e to the power minus 0.07 t plus 0.84, space. So on solving this, alt equals to, you get a value of e to the power minus 0.07 t plus 0.17 and space. So these are the three present values which we needed. Clear? So it's not that difficult. We just need to remember backslash int underscore is for subscript and to the power is for superscript. That's it for this class. Thank you.